Hi everyone, welcome to my channel TCU for Olympiads and JEE. Today I am back with the one question series for physics, and this is the 03 and this is the physics series. This is the 03 means third video of the physics series. We have already done two questions in our previous two videos. You must check those before coming to this video. Let's start with the question for today. This is question number 3 on this series. A ball is dropped from the top of a tower of height h. At the same time, another ball of equal weight is projected upwards from the base of the tower with velocity just sufficient to take it to the top of the tower and collides directly with the falling ball. Prove that the falling ball will rebound and rise to a height short of the top of the tower by 1 by 4 h 1 minus e square. E is the coefficient of restitution. Okay, pause the video and try the question. I hope you have done that. I am moving on to the solution. First, let's draw the situation. This is a platform there, let's say. Yeah. And this is given height h. This is given height h. Yeah. Now, there is a ball. Circle is not available. Yeah. There is a ball here and there is another ball here. Okay. Now, it's told this is top of the tower h. At the same time, another ball of both have equal weight. Let the weight be w. Let the weight be w for both. Okay, let this be w again. Now it's given that one is directly made of free fall, means u is equals to 0 here. Okay, and here it's given an upward velocity which is equals to root 2 gh. Root 2 gh. This is from work energy theorem, that here potential energy will be mgh, here 0, here kinetic energy will be half mv square. Here kinetic energy will be 0, here is half mv square. So half mv square is equals to mgh. So v square will be 2gh and v is root 2gh. This is our observation from here. Now it's told that they collide directly with the falling ball. It collides, second ball collides directly with the falling ball. Let this be 1 and this be 2. 2 directly collides with the falling ball. This falling ball means 1 will rebound to a height rise which will be h minus h by 4 1 minus e square, means it will just be this height less than the top of the tower. Okay, let's prove this. How we will start? First of all, let after time t the collision happens. This is let t be the time at which the collision is happening. Okay, now this h is equals to, let this be a, this be b, lower point be b, and here the somewhere the collision is happening, let this be c. Okay, where both the balls collide. H is equals to, we can write AC plus BC. This is applicable here. AC plus BC we can write, which is equals to, let's see what is AC. It's half GT square, right? Half GT square. And now BC, let's say what is BC. BC is this, let this be equals to U1. This U1T minus half GT square. Okay, half GT square. Let's cancel both of these. We will remain with U1T only. Okay, now T will be equals to H by U1. H by U1, which is equals to root over of H by 2G, H by root 2GH, which will simplify to root H by 2G, right? I hope you have understand up to this. Moving on, first let us find the velocity at the time of collision. At the time of collision, velocity will be v1 for body 1 will be equals to what? v1 will be equals to gt, means gt, which is h by 2g, which means this will be h by 2g. Okay, it is, yeah, now which is equals to h, what is this, hg by 2. Okay, now let's find v2. What will be v2? v2 will be u1 minus gt, means sorry, v will be u1 minus gt. Okay, u1 is root 2 gh, half gt, u1 minus gt. Okay, half gt square is for displacement, minus g into h by root 2g. On simplifying this, one will get g by 2 once again, means v1 is equals to v2. I hope you will be able to simplify this statement. I am not going in such things, or else the video will be become too large. I don't want that. Now let's apply the law of conservation of momentum. Law of conservation of linear momentum I am applying here. On applying that, we will get W, both of us as W weight, W by G means mass. G will cancel from all sides, but let's say I am writing. Okay, now this is moving here, V1 is moving here, V2 is moving here. G I have taken as positive, since V1 then will be positive. V1 is positive, then we will have W, and here we will have minus V2, then we will divide by G, then here again there will be W by G. Let's say both of these go downwards. Let's say this is the velocity of v1 and this is the velocity of block 2, body 2, and let's say these be v1 dash and v2 dash. So this is v1 dash plus w by g v2 dash. Okay, now pretty simple up to now. This question is really a good one. There is much thing to think about. Now we will see. v1 is equals to v2, we already know, so this also cancels. So we can find v1 dash plus v2 dash will be equals to 0. We are sure about the fact that v2 will go down. There is no such thing that v2 will go up. We are sure about that because it's just colliding. It may even go up, but okay. This thing is a good one. Let's say v2 is going down and v1 is going up. v1 dash is equals to minus of v2 dash. Okay, no need of this statement. This will create nothing but confusion only. I am rubbing this statement. We don't know anything about v1 dash and v2 dash's direction, so we are just pondering what to be done. Now let's apply the E formula. I am changing the color. Yeah, E is equals to velocity of separation by velocity of approach, means V2 dash minus V1 dash by what will be V to V. Let's say both of those were V, or 2V1, as I have written V1 there. So 2V1 you can write. Okay, now we know the value of V1, which is GH by 2. So we don't know the value of E once again. What we can do, we can find V2 dash minus V1 dash. V2 dash minus V1 dash is equals to E then root 2 GH. Okay, this statement is done. Now this is one equation. Okay, wait. Yeah, this is one equation. This is equation 1. This is another equation. Now I am just adding one just one subtracting 1 minus 2. We will have value of V1 dash, which will be equals to minus of E then GH by 2. This is our another conclusion. This being negative, we can understand that this V1 dash will be in upward direction. We have taken V1 dash direction as wrong. This will be in this direction. This direction will be the direction of V1 dash. Okay. Nothing of this sort is needed now. Okay. I am rubbing this arrowhead here. Okay. Now we were taken the wrong direction of V1 dash that time. Now let's just we have got the value of V1 dash. Now from the formula V square minus V square is equal to U square plus 2S, we can write let it meet at D, stops at some point D. We have to find AD basically, but let's first of all find CD. CD will be this V1 dash whole square by 2A. From the formula V square is equal to U square minus 2S or plus 2S there. Here we will take minus 2S. So which will be minus 2S since it's there. Yeah, this is the formula. And on simplifying this, we will get 1 by 4 H E square. Okay. Now first of all we need to find AD. So we can subtract AC minus CD to find AD. AC minus CD is equals to what? AC we already know, it's half GT square. GT square, T we know root 2 H by G means H by 2G into H by 2G. So GG cancels here, minus CD we got 1 by 4 HE square. This comes to be equals to H by 4. So this is equals to H by 4. Taking common, we will have 1 minus E square, which is our statement to prove. Hence proved, we have proved our given statement. So this is the final solution to this question. Okay, those who want to take a screenshot may take it. Okay, with this final note of thanks, I am going to end the video here. Thank you very much for watching the video till the end. Thank you so very much. I am ending the video.